In the previous video, we learnt about the amplitude of a complex number. Now, suppose I have an axis, the two axis, say the two axis, and this is the origin. Say this is the real axis and this is the imaginary axis, right? So this is the real axis and this is the imaginary axis, and say this is the complex number. So I join the complex number with the origin, so I get this and I call this radius r, right? Now the amplitude is the angle made by this line OZ with the real axis. So this is the angle made by OZ with the real axis, right? So we can say that first of all that AZ equals to the y component and OA equals to the x component, right? So AZ equals to the y component because it corresponds to a length in the y axis, so this is y, and OA equals to the x component, right? Now we know that the tangent of theta, this is the theta, is equal to y component by the x component, right? That's the perpendicular divided by the base. Now theta is equal to then the inverse tangent of y by x, right? Now theta is called the amplitude of z or the argument of z, so we write it as ampz or we write it as argz, right? Now if you see, then from trigonometry we know that sine 2m pi plus theta is equal to sine theta, where n is an integer. Similarly we get cosine 2m pi plus theta is equal to cosine theta, right? So we get, now from here we can also get that tangent 2m pi plus theta is equal to tan theta, right? So if we get this, that tan theta equals to tan 2m pi plus theta, where m is an integer, then we can have infinite values of this angle, right? We can have infinite values of this angle. Now if we write tangent of theta equals to y by x, we wrote tangent of theta is equal to y by x, right? Now we can also write that that tangent of 2m pi plus theta is also equal to y by x, because see, tangent of theta is equal to y by x and this tangent of theta equals to tangent of 2m pi plus theta, so this is equal to y by x, right? Now if that is true, then we can write 2m pi plus theta is equal to inverse tangent of y by x. Now in this case, in this case 2m pi plus theta, this whole is called the amplitude of z or the argument of z, right? This whole angle 2m pi plus theta is the argument. Now m can have values from 1 to also 0, of course, 0 1 2 and so on up to n, and so on up to infinity, any number it can have, right? So if that's true, then amplitude can have any number, we can not any number, that is amplitude can have infinite numbers, right? Now if that is true, but one value of this amplitude is very unique, right? So this theta value is very unique. Now why see, if minus pi is if the amplitude, if the I made a mistake in saying, right, if the amplitude lies between minus pi to pi, if the amplitude lies between this boundary, then there can exist only one value of this amplitude, and this value of amplitude is called the principal value of the amplitude. Now again let me say, you understood that we can have infinite values of the amplitude, right? We can have infinite values of the amplitude. Now one value of this amplitude should lie between negative pi and pi, it should lie between them. If that is true, then that value is called the amplitude of z. Principal value of amplitude of z, or principal value of argument of z. Argument of z. So we write this a small. If a is small, it means principal value of argument, right? Now another thing is that you need to know that then this principal value of argument, right? So whenever you want to find the argument of a complex number, first what you need to do is to plot the graph of the complex number, right? So suppose I have a complex number z equals to x plus iy, right? So first I have to plot the graph of this complex number, as I've shown in my previous videos, right? So I made the graph. This is the real axis, this is the imaginary axis, this is the complex number. Same. Now I have to check whether this complex number lies in the first quadrant, or the second quadrant, or the third quadrant, or the fourth quadrant, right? So now if the complex number lies in the first quadrant, then the argument would be between 0 to pi by 2 or 90 degree, when p is in the first quadrant, right? So when argument is in the second quadrant, when p is the complex number, say this be a complex number p, right? So as I wrote p for I meant prince, so I wrote p is the complex number x plus iy, right? So this is the p. If p lies in the first quadrant, then the value of the argument of p, of course, argument of p would be between 0 to 90 degree, right? So when p lies in the second quadrant, when p lies in the second quadrant, the value of the argument of p would be between pi by 2 to pi, right? So when p lies in the third quadrant, the value of the argument would be between negative pi to minus pi by 2 or negative pi by 2. When p lies in the fourth quadrant, the value of the argument would be between negative pi by 2 to 0, right? So this is what you need to know, right? Now suppose I have a complex number, say say p or z equals to I by 1 minus I. So suppose this is a complex number, right? Now first I think you might not be acquainted with the division of complex numbers, but just let me tell you, to divide complex numbers, we multiply the numerator and the denominator with the conjugate of the denominator, right? So I multiply the numerator and the denominator with the conjugate of the numerator, right? So that's how we divide. Now what I get is I on the numerator, I plus I square whole by 1 minus I square. Now remember the value of I square. The value of I square was minus 1. So I square was minus 1. So we get this as 1, or I minus 1 divided by 1 plus 1. This is half I minus half, or we write it as minus half plus half I. Now from this, first we are going to check in which quadrant this term lies. So first we need to draw the graph, right? So this is the real axis, this is the imaginary axis, this is say 1i, and this is say negative 1i, this is 1 negative 1, and this is positive 1, right? So now it's negative half, so it would lie somewhat here, and it's positive 1.5, so the point lies here, right? So the point lies here. This is the point P or Z I took. I think so I took Z. Yeah, so Z. So this, I'm sorry, this point is the Z. So Z lies in the second quadrant, right? So if Z lies in the second quadrant, we get the amplitude or the tangent of theta. Wait, yeah, the tangent of theta is equal to the y component divided by the x component, or the tangent of theta becomes the y component is half divided by negative half, that is half times negative 2 by 1, this is negative 1, so tan theta is equal to negative 1, right? So what is the, now again I have also, we can say that since theta lies in the second quadrant, we have pi by 2 is less than theta is less than equal to pi. This is the boundary we get, right? Now as I said, tan theta is equal to -1, so in this case tan theta would be pi minus pi by 4, that is tangent of 3 pi by 4, right? So if that is equals to -1, we know that the tangent of 3 pi by 4 or tangent of pi minus pi by 4 is equal to -1. So we get tangent of theta equals to -1, which is equal to tangent of 3 pi by 4, or we get tangent of theta is equal to tangent of 3 pi by 4, or we get theta is equal to 3 pi by 4.